Okay, so here's the thing about AI agents right now. Everybody is building with them. Everyone's using them, but there's sort of this fundamental problem really no one really talks about. Most agents are, well, shallow, and I don't mean shallow like they can write code or answer questions. They can do that just fine. I mean shallow like they can't plan over longer time horizons, can't break down complex problems, can't really think deeply about anything. But here's where it gets interesting. This is the new category that's sort of emerging, at least on the side of Twitter I'm on. But what I'm calling LangChain and a lot of other people are calling deep agents. They're fundamentally different in the way they work, not in their core architecture, which is surprising, but in how you are configured and what tools they have access to. And the thing is, once you understand what makes them tick, you realize isn't about making better chatbots. This is about the difference between AI that can answer questions and AI that can actually do your job. So let's start with the problem here. You've probably used Claude or ChatGPT or whatever, asked it to help with something really complex, and then watched it just spiral. It just starts confident, it runs into complexity and tries to push through. And eventually you're sitting there thinking, this would have been faster if I just did it myself. Now, why does this happen? The standard agent architecture, when I say standard, I mean what 99% of the developers are building is just a LLM in a loop calling tools. And that's really it. You give it a task, it calls tools, looks at result, and then calls the tool, calls another tool, and so on. Simple, elegant, and pretty shallow. In other words, these agents are reactive, not proactive. They're responding to immediate context, not planning ahead. They're like someone trying to build a house by just picking up whatever tools they find useful at the moment without ever drawing up like blueprints or something like that. So then something interesting really happened. If you guys have used Claude Code, Claude Code came out, Manus shows up, deep research becomes a thing from ChatGPT and Claude. And then suddenly people are using these agents for genuinely complex multi-hour tasks. People are building entire applications, conducting research and solving problems that would take a human developer days. So what's different here? The critical insight here is it's really not the model. It's not some breakthrough in the transformers architecture or something new in the training techniques that they do. The core loop is exactly the same. LLM calling tools. The difference is in the four specific things, and once you see them, you really can't unsee them. The first component is the system prompt. Claude Code system prompt is thousands of tokens long. We're talking detailed instructions. Examples specify patterns for how approach different types of problems. And here's what's fascinating. It's like these prompts, or the prompt isn't doing anything magical. It's just context engineering. But the thing is, context engineering is everything for these models. The difference between write me some code and 2,000 word prompt explaining exactly how to think about the code architecture, error handling, and testing strategies. That's the difference between shallow and deep. In other words, we've been treating these models like they should know how to be agents, when really we need to teach them every single time. So the second component is, this one's really my favorite one because it's counterintuitive. Claude Code has this to-do list tool. If you ever used Claude Code, it's very, very useful. You know what it does? Nothing. Literally nothing. It's a no-op. This model calls it and says, I'm going to do X, then Y, then Z. And then the tool just goes, cool, noted, and returns nothing. But here's the thing, that nothing is everything. By forcing the model to externalize its planning, to write down even though it doesn't technically do anything, you're creating a cognitive anchor in a way. The model can't forget what it's supposed to do because it literally just told itself. Think about it like this. If you have ever started planning a problem to someone and solved it yourself by thinking through it, that's pretty much the same principle here. The tool does nothing, but the act of using it does everything. Now, component 3 is the subagent. Now, this is really getting into the interesting architectural stuff. Deep agents can spawn subagents, and I don't mean just calling other APIs or running another prompt. I mean creating entirely new agent instances with their own context, their own goals, and their own specialized prompts. So picture this: you ask Claude Code to build you a web app. The main agent doesn't try to do everything. It spawns a sub-agent for this backend, another one for the front end, maybe another one testing. Each sub-agent goes deep on its specific task, maintains its own context, doesn't get confused by the others what they're doing. In other words, we've gone from a single worker trying to juggle everything to a project manager coordinating specialist. In a way, sort of. And it changes everything, like what's possible behind a system like this. And lastly, but not least, component 4. This one's really nobody talks about when you're talking about deep agents. It might be the most important, but deep agents have a persistent workspace, not just memory or of the conversation, but actual files they can create, modify, or refer back. Claude Code writes notes to itself. It creates design documents, keeps running the list of bugs to fix, saves partial work. Manus does the same thing. It constantly writing and reading from what essentially is their external brain. Now is the infrastructure question. Now we ask the big question here. What makes them deep? What makes these agents deep agents? Why isn't everybody doing it? And the answer is, well, they are, or they're trying to. Every major AI company is building a version of this. OpenAI has Canvas and their coding agent. Anthropic has Claude Code. Google has their research agent. And then they're all converging to the same architecture because, frankly, it works. So, but here's the thing, and there's where it connects to the bigger picture. Building deep agents requires infrastructure commitment. You need persistent storage. You need orchestration for sub-agents. You need to communicate to run multiple parallel instances. In other words, this shallow agent problem isn't really a technology problem. It's a resource allocation problem. We know how to build deep agents. Well, the question is whether we're willing to provision the infrastructure to support them at scale. So I wanted to sort of, within making this video, I want to show you guys, spun up Claude Code for you guys to show you how a deep agent works. But here's, as you can see the query here, I told it to research the AI frameworks to understand the core capabilities and what's the best use cases for each. And you can see it's calling the web search tool that was given to Claude Code behind the scenes. It called them asyncly. And then what it's doing, it is fetching. And this is also a feature you can add in deep agents as well. It's called a human in the loop. If you don't want to run malicious code or anything or fetch stuff that is malicious, you can ask the human. Sort of a way to ensure security in systems like this. Because you really can't control the agent. There's a lot of agencies, so it can do what it wants, and most of the time it's correct. Actually, I'm gonna come back when all of this is done and show you guys the result. So here is the result here. Research complete. Essentially what it did was at the end it wrote what I told it to in each markdown file, give a research summary of what they are, and at the end give another comparison framework markdown of all of them in aggregate, and then essentially gives you that. So this is, if you think about it, this could be not just for code. I use it for my notes in Obsidian. Anything that has you can give access to a file directory and run computer commands like terminal shell, grep, and everything to search. So stuff like that. You could probably think of ways to automate workflows like that instead of making a whole vertical solution for a specific task just to use or ask Claude. It probably can do it for you.